Hello and welcome to the lecture on 1.10. Today we're going to talk about lines. We're going to start off this lecture with slope. The slope of a line is a ratio of change in y to change in x that measures how steep the line is. We sometimes refer to the slope of a line as rise over run, where the rise is the change in y, or the vertical distance, and the run is the change in x, or the horizontal distance. So let's go ahead and draw out a few pictures to sort of give you an idea of what we're talking about here. Now, I know you probably understand what I mean when I say slope of a line, but let's get a better idea. Let's get a better understanding. So suppose that we have these two types of lines. Now here, if we have a point on the line, another point on the line, then this horizontal change from one point to the next is called the change in x, or is the change in the horizontal distance. We also call it the run here. Now the change in y is the same, except for y values instead of x values. We have the change in the vertical distance, or the change in y. Sometimes we call it the rise. So to rise from one point, the rise over run from one point to another is the change in y divided by the change in x. Now here, we can see that our line is going up. So we can think about what that would mean in terms of a slope. If our line is going up as our x increases, remember to the right x is increasing. So if our line's going up as x increases, then we have a positive slope. And we'll see that in the calculations later. Now, if we have a similar case over here, then again, we have our change in x and our change in y. But now our line is going down as our x is increasing. So again, as we're moving to the right along the x-axis, the line is coming down. Now this is a negative slope. Noting that the change in y is going to be negative because we're starting at a higher y value and we're ending at a lower y value. From this we can see that the slope will be the change in y divided by the change in x. So now all we really need to do is figure out what these are. What is delta y and what is delta x? Slope of a line. The slope m of a non-vertical line through points A, x1, y1, and B, x2, y2 is m equals the rise over run, which is equal to the change in y divided by the change in x, which is equal to y2 minus y1 divided by x2 minus x1. The slope of a non-vertical line is undefined. All three of these are different formulations. They all mean the same thing, but they're all different ways of saying the same thing. And we'll get to a vertical line in a second. But let's start with just a line, a normal non-vertical line. Suppose that we have something like this. As we showed before, if we have 2 points like this, we can find the change in x. And this is the change in y. Now what we want to do is we want to figure out what delta x and delta y are, which they're obviously given here. But what we see is that this point A is x1, y1, that the coordinates x1, y1, which means that this x value is x1 and this y value is y1. Similarly, we have B here, which is x2, y2, which means that this is y2 and this is x2. Now, what we're looking for is this distance, the change in x. And that's just going to be the distance between x2 and x1. When we talk about this type of distance, we're talking about in a specific direction. So, we're doing x2 minus x1. Now our slope is denoted with m, and our change in x is on bottom, so we have x2 minus x1. Similarly, the point to the right has a y value of y2, and we're going to subtract y1. We started here and ended here, so we're going to do y2 minus y1. Now the sign of the slope is just the direction that we're going. Are we moving up or are we moving down? If we have a negative sign, it means we're moving down. If we have a positive sign, it means we're moving up as our x increases. So I have a question now. We just finished talking about what the slope means and showing where we get what the slope is. Why do we exclude vertical lines? Why are vertical lines excluded in this case? Let's look at it for a second. Suppose that we have a vertical line here. And let's say that this x value is x1. Now let's say that this is a x1, y1. And then we have another point, separate, b. Now the x value is still x1, but the y value is different, y2. Now if we try to run the slope on this, if we try to run the calculation on the slope, we get y2 minus y1. So y2 minus y1 divided by the x values, which is x1 minus x1, which is going to be y2 minus y1. And from the picture, we can clearly see that that will actually be a non-zero value because they have vertical distance divided by 0. Now, this divided by 0 means that we have an undefined number, which is why the slope is actually undefined for vertical lines. It's also, this is also a good point to note that when you have a vertical line, the x value isn't changing. If we have a horizontal line, the y value isn't changing. So if we're to graph a line, say, x equals x1, we would actually get this line, because every x value on this line is equal to x1. Just something to keep in mind as we move forward. I do want to make a note. Should have made that note here. I do want to make a note here really quickly. The slope remains the same regardless of which pair of points we use on the line. Let's go ahead and do an example next. And I'll illustrate this note in this example as well, just for practice. Find the slope of the line containing the points A, 1, negative 2, and B, 4, 0. Does the line contain C, negative 2, negative 4? So let's start with just finding the slope. M will equal y2 minus y1 divided by x2 minus x1. Now when we have 2 points, we have an x1 and a y1 in our first point, and an x2 and a y2 in our second point. So we just plug in the corresponding values. If my 0 is y2, I plug that in. If negative 2 is y1, we plug that in, and so on. So m will equal 0 minus a negative 2, be careful with your negatives, divided by 4 minus 1. So we're going to end up with 2 divided by 3. So our slope is 2/3. Now if we want to check whether C is actually on the line as well, we can look at the slope between C and A or C and B and see if we get the same slope. If we do, because these 2 points are on the line, C will also be on the line. Let's look at A and C first, and then we'll look at B and C. So A and C. Here, this will be our y2 and this will be our x2. So we'll do a negative 4 minus a negative 2 divided by negative 2 minus 1. Now here we have negative 4 plus 2 divided by negative 3. which will end up being negative 2 divided by negative 3. Now, if we cancel the negatives, we get 2/3, and we can see that we have the same slope. Since we have the same slope, and A and B are already on the line, then C is also on the line. We can tell that from this. Now, I also want to do C and B just to show you the reduction. So here's B and C. This will be negative 4 minus 0 divided by negative 2 minus 4, using this as x2, y2, and this is x1, y1. Negative 4 minus 0 ends up being negative 4, and negative 2 minus 4 is negative 6. So notice that the slope doesn't immediately look like 2/3. It still will reduce to 2/3. We can cancel the negatives and we end up with 4/6, and then we divide top and bottom by 2 and we get 2/3. So we still have the same slope. It might be a different form of the slope, but it is the same. All right, I want you to try one now. Find the slope of the line containing A, 1, 3, and B, 3, negative 1. Now, I want to recap all of the slopes really quickly. This line has a positive slope. This line has a negative slope. This line we didn't talk about yet, but it's a horizontal line where the y values are the same, so you'll end up with a slope of 0 divided by x2 minus x1. So we'll have actually a 0 slope. And lastly, we have the undefined slope, which is a vertical line. Okay, the next thing that I want to talk about is point slope form of an equation of a line. So let's recall something really quickly here. A point xy is on the curve of an equation whenever xy satisfies the equation. It's worth asking ourselves, how do we define a line? What characteristics do we need in order to be able to find the equation of a line? We can see that we have multiple lines with the same slope. The slope alone will not uniquely identify a line. We need something else. Well, notice here that all of the points are different. These lines never intersect. The points contained in one line are not contained in any other line with the same slope. So what we need to do, we need to anchor a line with a point. So we say, well, what if we had this point A, and we said that A is definitely on the line, and we have this slope? Then we have a unique line in the plane. So now we're going to try to devise an equation where we have a point and a slope. Let's use this line here, x1, y1. Say that the point A, x1, y1 is on the line. All right. And we also know the slope, m. Say that this line has slope m. Now we know that m is equal to y2 minus y1 over x2 minus x1. Now what I'm going to do next might be a bit hard to understand. I'm going to say that this point is on the line as well, this point P. Now I don't know what the coordinates of P are, x, y. We just know that it is on the line. So if we know that our slope is m, we know our m is going to equal y minus y1 over x minus x1. Noting that we already know what the slope is, so we know what m is, and we know that p is on the line and a is on the line, so they must satisfy this equation. Now if I multiply my x minus x1 over, then I end up with y minus y1 is equal to m times x minus x1. Now we have an x and a y, and y1, x1, and an m. So if we know the point x1, y1, and we know the slope, then we have an equation that defines this line. So if the point xy satisfies this equation, then it's on the line. Point slope form. An equation of the line that passes through the point x1, y1 and has slope m is y minus y1 equals m times x minus x1. An example here. Determine the equation of the line with slope -1/2 containing the point 2, 1. So our point is x1, y1. So we'll plug that in just by pattern matching alone. And our slope is -1/2. That's what m represents here. M is the slope. So all we need to do is plug in our points. Y minus 1 equals -1/2 x minus 2. Noting that we have a minus here and a minus here. So this 2 is not actually negative, it is still the positive 2. It's just that the negative here is a part of the equation. Try one. Determine the equation of the line containing -2, -4, and 1, 1. Now for this problem, you're going to need to find the slope first, because the point slope form, we need a slope and a point. Here you're given 2 points, so you need to find the slope before you can actually plug into this equation. The next thing that I want to talk about is slope-intercept form. Recall, the y-intercept is the point where the curve crosses the x-axis and has form 0b. Specifically, I wanted to note that x is equal to 0 in this ordered pair. Also remember from just a few minutes ago that we have the point slope form is y minus y1 equals m x minus x1, where x1, y1 is a point and m is the slope. So what we're going to do is we're going to use a special point in the point slope form to derive the slope-intercept form of a line. Okay, so all equations have different forms. Specifically, lines have multiple forms that we study: point slope, slope-intercept, standard form. The slope-intercept form is probably the form that you know best, y equals mx plus b, and we're going to show that right now. So recall from the point slope form that x1, y1 is a point. We're going to use the special point 0b, which is the y-intercept. So we end up with y minus b is equal to m times x minus 0, where we use this point on the line. And this will end up becoming y equals, the 0 we can just ignore because it's 0, and then we have mx, and then we add the b over. So we have mx plus b. And this form is probably most common in high school and below. Personally, I'm more partial to the point slope form. Slope-intercept form. An equation with a line that has slope m and the y-intercept is b is y equals mx plus b. Find the slope-intercept form of the line that passes through the point 1, 3 and 3, -2. Now, as I said on your last try one problem, we're given 2 points, so we need to figure out what the slope is before we can proceed with plugging them into the formula for plugging them into the equation. So we start with the slope. Now remember that the slope is y2 minus y1 divided by x2 minus x1. And in this case, we have x1, y1 here and x2, y2 here. So this ends up being -2 minus 3 divided by 3 minus 1. So we end up with -5 over 2 for our slope. Now our point slope form then will look like this. Y minus 3 equals -5 over 2 x minus 1. And you might ask why I used this point for my point slope form. It actually doesn't matter. You can use either point. When we get to the slope-intercept form, it will be the same, regardless of which point you use. I just chose this one because it was first. So we distribute our -5/2, and then we add 3. So we end up with y equals -5/2 x plus 11/2. Remember that 3 is the same thing as 6/2. So when we're adding 6/2 to 5/2, we get 11/2. Now this is the slope-intercept form of the line. Again, it doesn't matter which point you use, you'll end up with this as your slope-intercept form. Try one. Use the slope-intercept form to find the y-intercept of the line containing -4,3 and 112. Here I'm actually looking for the y-intercept, just the y-intercept, as an answer. Next thing I want to talk about is vertical and horizontal lines. The equation of the vertical line passing through the point AB is x equals a. The equation of the horizontal line passing through the point AB is y equals b. Now this is what they look like graphically. So suppose we have these two axes and we have a point AB. Well, then the vertical line that passes through AB will look like this. And similarly, the horizontal line passing through AB will look like this. So what I want to note here is that x equals a is the equation of this line, because a is the x coordinate of this coordinate, and the vertical line passes through this point. So this has to be x equals a. If you notice, any other point on the line will have x equals a as a coordinate, as a first coordinate of the ordered pair. So suppose that this is 1, this would be a1, and then we could have a2, and so on. No matter where I go on this line, the x coordinate of the ordered pair will always be a. Similarly here, this is the equation y equals b, because b is the y coordinate of the ordered pair. No matter where I go on this horizontal line, the y value, the second coordinate in the ordered pair, will always be b. Try one. Find the equation of the y-axis. Find the equation of the x-axis. Find the equation of the line given here. Next thing I want to talk about is the general equation of a line, sometimes called the standard form of a line. A linear equation, the variables x and y, is of the form ax plus by plus c equals 0, where a, b, and c are constants and a and b are not both 0. This is the equation of every line. You can solve for y, and you would get it in y equals mx plus b form, or you could put it in some other point slope form, but that's unnecessary. Now the benefit here with ax plus by plus c equaling 0, if b is equal to 0, then the equation reduces to x equals a, where a is equal to -c over capital A. And this is the equation of a vertical line. Now you can't do that with slope-intercept or point slope, because the slope would be undefined. A graph of every linear equation, ax plus by plus c equals 0, where a and b are not both 0, is a line. Conversely, every line is the graph of a linear equation. All we're saying here is that a linear equation is a line. They're definitionally the same. Let's do an example using this form. Graph the equation 3x minus 4y equals 6. So we're still in the stage of plotting points. And when we have a line in this equation, it's not as bad as you think. Usually how I deal with this is I find 2 points by letting x be 0 for one and y being 0 for the other. So if x is 0, then we end up with -3/2 for y. And if y is 0, then x ends up being 2. All I did there was plug in 0 for x and then solve for y. So if 0 in this first one, if x is 0, we get 3 times 0 minus 4y equals 6. And then I have -4y equals 6, so y is equal to -3/2 after you reduce. Now in the second one, all I did was plug in 0 for y, so I get 3x minus 4 times 0 is equal to 6. So 3x equals 6, or x is equal to 2, which is how I got my x value. Now all we have to do is plot these points. So x is 0, y is -3/2. -3/2 is the same thing as -1.5. And then x equals 2 and y equals 0 is this point here. Notice that all I'm doing is graphing the intercepts, the x and the y intercepts. If you have an x-intercept and a y-intercept of 0, you would have to find a point using a value other than 0. The next thing that I want to talk about is parallel and perpendicular lines. Shorthand for parallel is just two straight lines like this, indicating that they don't intersect, and perpendicular shorthand is like this. Just in case I use those symbols, I'm defining them now. Two non-vertical lines are parallel if and only if they have the same slope. I think this is a bit self-explanatory. If m is the same in two different lines, then they are never going to intersect, so they're parallel. Furthermore, we specifically say that they are non-vertical so that we could reference the slope. Notice that whenever we say slope, we have to reference non-vertical lines because vertical lines have an undefined slope. Try one. Give the equation of a line that is parallel to y equals 3/2 x plus 4. Perpendicular lines. Two lines with slopes m1 and m2 are perpendicular if and only if m1 times m2 equals -1. In other words, their slopes are negative reciprocals. So in this case, m2 would equal -1 over m1, or m1 equals -1 over m2. These two are the same equation. They all follow from this equation here. Note, the angle between two perpendicular lines is 90 degrees. It just means that they look like this. So you have one like that and another one like this, and they form a 90-degree angle. That's what perpendicular means. I'm going to prove this statement up here that they're negative reciprocals on the next slide. It suffices to prove this statement when they intersect at the origin, for reasons you don't need to know. Say we have a point A here. Actually, let me make a point A here. And my point B here. And I make a vertical line. Now, note here that they intersect at the origin, and this is where they are perpendicular to each other. So there's a 90-degree angle here because we assume that these two lines are perpendicular. And we want to show that they have slopes that are negative reciprocals of each other. So we have a right triangle right here. And this x value, I'm going to say, is 1. So the coordinates of A are 1, m1. So this line would be y equals m1x, and this would be, this line would be y equals m2x. This then means that b is 1 m2 because we move over 1 and down m2. So we have a right triangle, we have the vertices of all three of these points, the origin of course being 0, 0. Now we use the Pythagorean theorem, and that of course is a squared plus b squared equals c squared, where a would be the distance from the origin to a, and b would be the distance between the origin and b, and c will be the distance between a and b. Now c is pretty easy. So we have the distance between the origin and a squared plus the distance between the origin and b squared equals the distance between a and b squared. Off to the side here, I'm going to show you what the distance between O and A is, or distance between O and A squared is equal to 1 squared plus m1 squared. Using a Pythagorean theorem on this triangle here, you can find this distance very easily. Similarly, if we use this triangle, also a right triangle, we can find the distance between O and B squared. And that will be 1 squared plus m2 squared, like this. And then the distance between a and b squared, since they have the same x value, it'll just be the difference in the y. So the distance between a and b squared will be m1 minus m2 squared, this. So let's fill all of these in. The distance between O and A squared is 1 plus m1 squared from here, plus the distance between O and B, we get 1 plus m2 squared. And the distance between A and B, I'm going to FOIL this out. Remember that when we square a sum, you have to multiply it by itself, so it's m1 minus m2 times m1 minus m2. And we should get m1 squared minus 2m1 m2 plus m2 squared, like this. Now subtracting m1 squared from each side and m2 squared from each side, we get these cancellations, and then 1 plus 1 gives us 2. Divide by a negative 1, and we end up with m1 times m2 equals negative 1. Now, note here, again, that this equation is the same as the equation that we had in this definition, which is the same as this equation. If we divide both sides by m1, we get this equation, and if we divide both sides by m2, we get this equation. We've shown that when you have perpendicular lines, the slopes are negative reciprocals of each other. Try one. Find the perpendicular line to 12x minus 7y equals 10,000. Now I want to do an example that isn't related to parallel or perpendicular lines. It's related to slopes in general. Gregor is working for Borkus as a dishwasher. The amount of money, y, in credits earned by Gregor is given by y equals 5 plus 12x, where x is the number of hours Gregor works. What does the slope of this linear equation represent? So we have the equation y equals 5 plus 12x, and y is in credits. It's measured in credits. That means that this side also has to be measured in credits. So 5 plus 12x is measured in credits. 5 being a standalone constant must already be in terms of credits. Now 12x, 12 times x, is measured in credits, but x is the number of hours worked. So 12 times x, this needs to be measured in credits. but X is measured in hours worked, which means that we'll have 12, and we need to figure out what these units are to give us a little bit of insight, times X, and this is hours, is going to resolve to some number in credits. Now, these units, the multiplication of 12 times X, we must also multiply the units on 12 times the units on X to get credits. So what times hours would give me credits? That's going to be credits divided by hours, or credits per hour. So if we say that 12 is measured in credits per hour, what does that represent in this equation? That's going to be his hourly wage. This is meant to help y'all understand word problems a little bit better. Hopefully this helps a bit. Try one. The ground crew is fueling the X-Wings. The volume in liters of the fuel the X-Wing contains is V equals 6,000 plus 50 T, where T is measured in minutes. What does the slope represent? Try to figure this one out. Use the same process sort of as what I did in the previous example, and you should get a basic idea of what this represents. All right, that's going to be it for today, so I will see you all in the next lecture.